Hi and welcome back to ovs.net. This is the third part of my series where I am building a completely new Commodore 64 from scratch. So in the last episode I soldered most of the different components, resistors, capacitors, diodes, and also these joystick ports, fuse, transistors, expansion port. In this part I'm gonna find the other connectors like the power plug, the on and off switch, and also the video and serial ports. Besides that, I'm gonna find a keyboard that's suitable for this machine, and yeah. Also, I'm thinking about starting to populate the different ICs on this board. Up until now, I have only used brand new components and parts. However, now it's time to go back to the 80s again. Some of the parts of the Commodore 64 is now very hard to find as new components. For example, these connectors for video and serial. Also a power connector, of course, and power switch. So I have this parts board here. As you can see, most of the parts are still remaining. Yeah, so I'm gonna take off this one, and yeah, let's start with that. I'm heating up my desoldering station, Anesti ZT915. It's been very good, as long as you keep cleaning the nozzle and the content of this chamber here. Only problem, it is a bit noisy, and however, if you are gonna do a lot of desoldering, you will need a station like that, or of course you can use one of these simple pumps, but this would be much more time consuming, especially when desoldering microchips. I start by adding a little bit of flux to the solder points. That makes them yeah, the old solder will flow more easily in my experience. These contacts have really thick legs, so I'm gonna use around 400 degrees on my desoldering station. Alright, let's give it a go. That was the desoldering, and as always, you rarely get them loose at the first try. So I go over them one more time and wiggle a little bit just to loosen each of the pins. Then I try to gently wiggle them loose because I don't want to rip off any of the legs or the solder pads. We're getting there. All right, first one off. Power plug. If some of the pins don't come completely loose after desoldering, I just use a little screwdriver or something to just wiggle them to loosen them from the sides of the holes. Last piece is this power switch. Then I just clean up the pins for the old solder. Now these connector parts or plugs look quite good, not really worn or anything, so that's promising. And I'm gonna spray everything down with electronic cleaner spray. Just give them a good bath. Also inside the power switch. Alright, time to do some soldering, and but first just make sure everything fits, and it looks like it does, so really no problem there. Or maybe not. The power plug does actually not fit the holes in the board, and but it's not these pins that are conducting electricity. It's these two front pins that are actually there just to hold it down to the board. So, well, I think I'll have to find another one. But the other ones, they do fit, so everything cool. I'm gonna start soldering the power switch. Flux. Oh, these require lots of heat. But don't apply too much heat, or else you might risk melting the plastics of the component. And I also usually take some pauses in the soldering just to don't risk overheating the component. The DIN plugs for the video and serial port is they have 3 supporting tabs, but the board only has 2 holes, so I cut off the one in the middle. Damn, that's hard steel. Then I'll try to make the connector as level as possibly down to the flat down to the board, and try to solder with one hand holding it. Alright, when I got the 2 points, I can lay it down and then you solder the rest. Then the video port. This is not going good. This needs a lot of heat. All right. Just a small dab then first to get me going. Finally, some cleaning up the mess of Flux and everything. I think that soldering went well. They all look good and shiny. And later I'm gonna find another power contact which I have on another board, but for now I will continue. Here I got another Commodore 64 as a parts machine, and let's see what we can find here. And this board actually looks very nice. But here is another power connector. And also I'm gonna remove this cover for the expansion port. I have desoldered the other power contact and also this metal cover, and seems to fit perfectly. So now I'm gonna clean this up and make it look like new. What I actually had to do to get the correct contact was to disassemble both contacts and take this part from the other contact, put it there, and then put the cover back. It snaps into place. I wasn't aware that you could even do that. So now it should fit perfectly, and it does. Then some soldering. I have cleaned off this metal cover and masked it, so now I'm gonna spray paint it with this hard head silver spray paint. This one turned out very nice after some painting, and I'm gonna solder it in now. First I just twist the front hinges here, and then I'm gonna solder the back pins. Not very good. This requires a lot of heat, so I need to try again. Alright, I think that's good. I just realized I forgot something. If you remember in part 2, I think, I added this extra resistors from R37, and this was a modification made by Commodore after the production of the motherboard. However, it's not enough just to add the resistor, you also have to cut the trace on the back side of the board, going from R37 up to this point. And if I turn the board around, it's up here. So you need to cut the trace between this solder point and this solder point. And since this is a black board with covered in black, it's not easy to see the traces, but if you tilt it so that the light shines, you see the traces. So I'm gonna cut this one here, I think. However, I'm gonna double check it. There is a picture on the GitHub page from bwack, so you can always look there if you want. Alright, so now I'm pretty sure where I'm gonna cut, and it is exactly where this small wire is pointing. You could of course measure conductivity or the resistance between the points before and after, just to make sure. So I'm cutting it now. So I have zoomed in a bit and then you can see it better. Just making the cut a little bit wider so that I'm pretty sure it's cut. Alright, that's it. So now I'm gonna measure the resistance over this resistor here, and before the cut it was short, so it was 0 ohms, but now it should read the value of the resistor, which is 1K. So let me just measure this one, and it's 977 ohms, so that is pretty accurate. Okay, I'm ready to populate this board with some chips, and I am gonna start with the 3 Rom chips. And those are the kernel ROM and the basic ROM and the character ROM. And I got this from a spare Commodore 64. I'm not really sure if they're working, but I'll put them in anyway. I'll test that later, of course, if there is some problems with them. Then I got 8 RAM chips, 4164 of the brand TMS. I don't know if they're any good, but I found these on eBay, so let's put them in. Hopefully they work, and yeah, but you never know with these old chips. I don't know if these have been ever used. It's maybe some new old stock. I'm not really sure where they came from. At least they look unused. That was the RAM. All pins are correctly into the socket. Then it's time to populate one of the most important chips on the Commodore 64, which is the SID, and it's U18. And for this one I actually decided to go for a modern solution, and I have this SID replacement chip that is called the swinsid, and I already tested it and it works just fine. This chip has like this dual mode setup. You can use it on both the old Commodore 64s with the 6581 variant, and also you can use it on a newer Commodore 64C, which is 8580, and they have different input voltages. And since this motherboard uses the 6581 SID chip, I have to set the jumper 1 to on, and this is currently on jumper 2, so I have to move this over to the other jumper. All right. So that's the SID chip. Next chip up is the U17, the PLA, Programmable Logic Array. The PLA chips on the Commodore 64 are very prone to failing, and they are hard to find in the original version, because many of them have failed, and thus I have got another solution here, which is a modern variant called PLAnkton from Populate, and that's where I purchased it. And this is a brand new replacement for the PLA chip. This is an FPGA variant, and it says PLAnkton U17 here. A FPGA chip can be programmed to do any task you want, and it's sort of a virtual chip inside a chip. So this one has been programmed to perform the tasks of the PLA chip. So it's worth to mention that bwack, who made this replica, is actually working now on a FPGA replacement of the CIA chips, and that's a really interesting project, so I'll link to that in the description. In the beginning of this video I said that I'm gonna take a look at the keyboard, and actually I realized that I have several options, like this spare Commodore 64 keyboard, but it's very dependent on which case I'm gonna select to my machine, so I think I'll leave out the keyboard for a later episode. Alright, that's it for this episode. I'm just gonna make a little brand on this one, like that. A little statement for future users of this machine if I ever leave it on to somebody else. So we're getting closer and closer to finishing this motherboard, and I have to leave something for the next episode, so please subscribe if you want to see more. Thanks, and bye bye.